With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given that there is a thin bar of length L which has a mass per unit length as to be lambda that increases linearly with distance from one end. Now, if the total mass is given as to be capital M and mass per unit length at the lighter end is given as to be lambda naught, we need to find the distance of the center of mass from the lighter end. This we need to find. So first of all, we just make a, let's say this is our length L. Okay. So let us redraw this. Let's say this is our length. Okay. Now the total length is given as to be L. From here to here, it is given as to be capital L. Now the total mass is given as to be capital M, and this mass per unit length at the lighter end. So let's say at this end, that means at x equals to 0, this is given as to be mass per unit length is lambda naught. Now it is increasing linearly, so we can say that our lambda would be equals to a x plus b. Okay. Now we know that at x equals to 0, our lambda would be equals to lambda naught. If you put the value of x equals to 0 here into this expression, then our lambda would be equals to lambda naught. That implies that our b would be equals to lambda naught. Okay. So let's say this is our equation 1. If you put the value of b into our equation 1, then our equation 1 would look like ax plus lambda naught. Let's call this as to be equation 2. Now it is also given that total mass is given as to be capital M. From this we can find the value of our a. We know that total mass would be equals to integration of dm. Now how to write the this small mass? So for example, if we take an element at a distance from here to here at a distance of x, and let the length is small length dx. So the mass here, it would be dm. So if we integrate this small mass, then we can get the value of the total mass if we put the integration limit from 0 to L. So here x would be equals to L. So we can say that our dm, this would be equals to, so dm, how can we write? So this is mass per unit length. If we multiply lambda with our dx, this would give us the value of the total mass, and the limit would be from 0 to L. Now we put the value of lambda, it is ax plus lambda naught. Then we can integrate it from 0 to L with respect to our dx. So if we integrate this, then our m, this is our m, total mass, it would be ax square divided by 2. If you put the limit of L, it would be a L square divided by 2 plus here it would be lambda. Here it is just lambda naught. So integration here it would be just x. So lambda naught into x. If you put the limit as L, so it would be lambda naught into L. Now the lower limit is 0, so we need not to put the case. Otherwise the that term would be 0. So it is otherwise just a repetition of the same thing. So from this expression we can get the value of our a. A would be equals to, because we know that everything, we know L length, we know lambda naught, it is also given, capital M is also given. If we solve this, then our a would be equals to, so if we send this to the other side, it would be m minus lambda naught into L. Okay. Now we can just multiply 2 and divided by L square. So it would be 2 divided by L square. Let's say this is our equation 3. Now we need to find what is the value of the location of the center of mass. So x coordinate, because it would be lying in the x direction. So x coordinate we can just find. So x coordinate of the center of mass, this would be equals to x into dm divided by total mass. So which is equals to capital M. Now what is our dm? We know that we have just written our dm. We can write it would be equals to lambda into dx divided by the total mass. Now what is the value of lambda? So x lambda value is a, this lambda value would be equals to ax plus b. B was lambda naught. So we just put the value of a as a here. Okay, we are not putting the value of a, sorry, we are not putting the value of a because it is just a constant. So at the last we will be just putting the value of a, and we can integrate it from 0 to L with respect to x, and we need to divide it by total mass capital M. Now if we solve this, then our x center of mass coordinate, we can take 1 divided by m, and what would be the integration? So it would be ax square. So integration of x square would be equals to x cube divided by 3 plus, then it would be lambda naught into x. So the integration here, it would be lambda naught x square. Lambda naught is a constant. It would be just integration of x. It would be equals to x square by 2. Now we can just put the limit. Now we know that if we put the lower limit at 0, so this function would be 0. So it is just better to put the upper limit. So x center of mass, this value would be equals to 1 divided by m. Then it would be equals to a, then L cube by 3 plus lambda naught L square divided by 2. Now what is the last thing which we need to do? Lastly we just need to put the value of our a. So x coordinate of center of mass would be equals to 1 by m. A value we have calculated the value of A. Let's check. 2 divided by L square, it is 2 divided by L square into multiplied by m minus lambda naught into L multiplied by L cube and divide by 3 plus lambda naught L square divided by 2. Okay, so this is our lambda naught. Now, so our x coordinate of center of mass 1 divided by m. Now we can clearly see that 2 power would be cancelled and here it would be just 1 power. Now if you multiply into this, so it would be 2 m, then L would be multiplied here divided by 3 minus, here it would be 2 lambda naught, then L into L square divided by 3 plus lambda naught L square divided by 2. Now we just need to solve this part and then we can take m to be in the bracket. Now if we take m into the bracket, so m would be cancelled, so it would be 2L divided by 3. From the first part it would be cancelled, it would be 2L divided by 3. Now if we solve this part, so the value of this part would turn out to be minus lambda naught L square divided by 6. And we are taking mass into the bracket, so it would be like this. So this would be the value 2L divided by 3 minus lambda naught L square divided by 6m. Now if we check the option, which is the correct option would be our D option. 2L by 3 minus lambda naught L square divided by 6m. Hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.